All right, how's everybody doing? I'm Anthony. I'm going to be talking a little bit about voice over IP and our implementation in the 2015 Information Security Talent Search at RIT. When I built this presentation, I really wanted to make it appealing to a wide range of audiences, so I'm going to do a little bit of an intro to VoIP, talk about our competition, talk about how we integrated VoIP into the competition, how that turned out for us, and then try and bring it around back for all the security professionals here about how we can kind of apply what we did to the real world. So real quick about me, I graduated from the Rochester Institute of Technology in 2014, this past May. I was responsible for designing, deploying the voice infrastructure that we had at ISTS this year. I'm an Asterisk and VoIP guy in my free time, and in my real job, I'm a network operations specialist at Harris Corporation. Previous experience at working in network operations at Wegmans. Anybody know what Wegmans is? Oh, that makes me sad. It's a grocery chain up north. It's the best grocery store in the world. And I know it sounds ridiculous, but there's two types of people. People who know that Wegmans is the best and people who are wrong. So if you're ever up north, be sure to stop in. And then I've also worked for Meraki, now owned by Cisco, their cloud networking group. So I'll get started here real quick, talk about the competition for people who don't have any experience with security competitions at all. And even if you do, maybe a little bit of a refresher. So the Information Security Talent Search is an annual competition we have every year at RIT. This was our 12th competition, and there's three teams, pretty much what you'd expect out of a security competition: red, white, and blue. I was on the white team, the infrastructure guys, the people who build and operate the competition. This year on our red team, we had a pretty good lineup of professional penetration testers. We had security experts from Box, Mandiant, FireEye. Raphael Mudge, the guy who created Armitage and Cobalt Strike, is a yearly member of the security team, or of the red team. And then your blue teams are your competitors, your student teams, who are actually given an IT infrastructure to defend. What makes ISTS unique, and what we tried to integrate into our voice infrastructure, is that blue teams are allowed to attack each other. So anybody here done CCDC? So with CCDC, you're defending against a red team, but it's a complete free-for-all in ISTS, which allows us to do some really fun things. So if you don't have any experience with a security competition, you're basically given an IT infrastructure that you're tasked to defend. A lot of common services, email, HTTP, DNS, all that stuff. And then while you're defending it, you have to keep your services up to score points so that they continue scoring. And then you're also given injects, things like implement syslog or webmail or implement HTTPS if you're just given an HTTP setup. And then those will earn you points. And then on top of that, you have more offensive challenges in ISTS, because I said blue teams can attack each other. So things like own another team's box and set up a Minecraft server, or own another team's box and patch it for them, or we had some really good crypto challenges this year, and things like that. So all these things, and then whoever has the most points at the end of the weekend comes out at the top. So where exactly do we fit in voice and voice over IP into that when we were kind of approaching it this year? Well, last year we did VoIP as kind of a last minute thing. And this year we kind of decided that we wanted to start out right and build something that really looked good and that worked good. So we fit in voice because it really is, anybody who works in enterprise IT, one of the most important services that your IT department is going to deliver. Voice and email, either one goes down, people are screaming. And it's also typically not a very well understood service in a medium-sized business. It's very common for a sysadmin to be told, well, you're good with the computer system, here's this voice system, it's been running for 30 years, go for it. And then it breaks, and you see a post on our sysadmin saying, well, I've had this voice system, I have no idea how it works, it's been running for 30 years, what do I do now? And typically the answer is, well, cry. And then you get the same thing with implementing voice over IP. It's typically not a well understood thing. So we kind of wanted to approach that in the competition because it's probably not something a lot of students have seen in other competitions. And you have a lot of vulnerability both in VoIP protocols by default and especially in voice configurations, which I'll be talking about further. So this is the fake topology that was handed to the teams a couple of weeks beforehand. I'm not going to spend a lot of time on this because this is the fake topology. And they had to discover the real topology. I didn't have any drawings of the real topology, but it's largely similar to this, but there wasn't actually a software-defined radio in there. But we had a couple of teams freaking out the night before who thought there was. So with kind of the competition basics out of the way, I want to talk a little bit about voice over IP and give an introduction for anybody who maybe doesn't have any voice experience. So whenever you discuss a VoIP architecture, you're looking at two protocols from a protocol standpoint, your signaling and your transport. Signaling will handle call setup, teardown, routing, in most cases digit passing, although occasionally that is rarely these days done in the transport protocol. And the two big players in signaling are H.323 and SIP, with a movement very strongly right now towards SIP because it's a very easy protocol to understand. It's HTTP-like, it's text-based, easy to recognize if you're looking at Wireshark. H.323 is absolutely miserable to look at in a packet capture. They pretty much took the ISDN protocols and stuffed them all into a packet, so you have like 400 headers, and it's a mess. And then your transport protocol carries actual encoded audio or video data. RTP is the king of transport these days, and it'll usually use it will always use a particular codec. G711 MULAW, commonly called ULAW, being one of the most common, with others existing. And transport travels on high-numbered UDP ports. Its sister protocol, the Real-Time Transport Control Protocol, RTCP, will do call statistics collection, things like jitter, delay, all of that. You'll also see Skinny Client Control Protocol, and Media Gateway Control Protocol as signaling protocols in Cisco land commonly, but and really a big move towards SIP these days in that realm. So this is an extremely simple example of what you might see in a voice architecture. You have your two phones, which will signal with your call server to do things like registration, authenticating to the voice network, and then when they want to place a call, they'll signal through your call server, and then the call server will set up the call, and then the call server will step out of the call commonly and allow media to flow directly between the two endpoints. Now, like I said, this is very simple. Every architecture is going to be different. Some companies interested in doing call recording may have their voice servers proxy all of the media so they can record calls. You may have a statistics collection server in there. You may have a totally separate server just for registration and authentication. But this will work kind of for purposes of people who don't have any voice experience at all, to give you an overall idea. And this is largely what Blue Team's architecture looks like in the competition. So when we talk about vulnerabilities protocol-wise in VoIP, the lack of strong authentication and the fact that these protocols are plain text are really the biggest ones. It's very easy to enumerate SIP extensions, to obviously to sniff traffic if it's plain text. You can or dial, you can do things like that pretty easily. And then for RTP, for your media streams, if you're able to capture an unencrypted RTP stream, you can just reconstruct entire voice calls. You can also inject packets to inject false audio into a call, again, by the nature of the fact that these are weakly authenticated, or in the case of RTP, no authentication by default or unencrypted. And then specifically an area we focus on a lot in the ISTS is the fact that configuration is challenging. In a lot of vendor turnkey solutions, when you say, okay, we're going to do Cisco voice, or we're going to do Avaya voice or something, security as a checkbox is really big. So you'll check the box that says secure calling or whatever, and do some minimal configuration and follow the vendor's guide, and it all works. But we really kind of see a move toward things like wanting to, buy solutions that aren't just made by one vendor. So maybe we like a particular soft phone on the computer better than we like the vendor's solution, and so that creates challenges in configuration for administrators. And then one of the biggest areas we focused on in ISTS was vulnerabilities in configuration of voice services. And we did this ridiculously. We did some really crazy vulnerabilities in the dial plans, but in real life, some of the most common things I see are conference bridges and voicemail being weakly secured using, some arbitrary, using the phone extension and the phone extension as the password for voicemail. And if you have features on your voicemail, occasionally you can use that, an attacker can use that as a pivot point, so they can get into your voicemail and then pivot outwards and make international calls. Extremely, especially the conference bridges, extremely common attack vector, because they'll set up a conference bridge at some extension. It's publicly available because it's designed to be a conference bridge, and the password will be 1234 with no lockout, because management will get angry if they type it in wrong 3 times and now they're locked out. So it's a very common thing. So we kind of focused on this a little bit in ISTS in terms of the way configurations of voice systems can be vulnerable. Now, for actually securing voice, conceptually it's pretty straightforward. You just want to authenticate and encrypt your traffic. SIP, the most common way to do that for your signaling is just putting it on top of TLS or on top of IPsec. You can also use SMIME, but SIP TLS being the most common. Now your SIP becomes TCP instead of UDP, and you have pretty much fairly straightforward security. The configuration is what is almost always the most challenging part of this, because it's not necessarily standardized across vendors. Now, in terms of media, the actual voice and video data, the way we approach security for that is there are several different ways. There's a spaghetti soup of RFCs on how to implement signaling, media security, and there's two main approaches. You either exchange a key within the signaling packet, so within like the session description within the SIP packet, or you exchange a key directly within the media stream, within the RTP stream. It's really exciting. Exchanging the key, I'm partial to ZRTP, which exchanges the key right within the media stream. And the reason is that you have to assume that your signaling channel is secure if you're doing key exchange in your signaling traffic, unless you're using something like Diffie-Hellman, which ZRTP does use ephemeral Diffie-Hellman to provide encryption of the media stream. But what's interesting, so a good example is LinPhone is a freely available open source soft phone user agent for SIP network, and it will do, you can check the SRTP box in it and it will do a key exchange, but it does a plain text key exchange right in the SIP packet, and if the SIP isn't encrypted, it doesn't complain about it, it just exchanges it right over the network, and you can rebuild entire call streams based on that. Extremely easy to do. So I also want to talk real quick, because we focused on this very heavily, and this is the platform we used in ISTS, is Asterisk. So Digium, the company that creates Asterisk, it's a free open source PBX. Digium describes it as a box of Legos for people who want to create communications applications. And I focus on the application word there because typically we're not just talking about two people calling each other anymore. We're talking about voice-driven applications, things like paying your bills online, things like managing an account. Paying your bills online, paying your bills over the phone, things like managing an account over the phone, all kinds of things like that. So you have an interface of your voice system to other back-end systems. And Asterisk is very modular, which is one of the reasons we used it in ISTS. You just configure what you need and don't configure what you don't. It's pretty straightforward. We used the SIP channel driver in Asterisk because we were doing SIP. And we used a couple of specific dial plan applications to implement different vulnerabilities, and it was pretty straightforward. And your main configuration files here, they're all going to be located in /etc asterisk, but you're looking at sip.conf to do the SIP configuration, configure your endpoints, your phones, and then the extensions.conf, which is that dial plan I was discussing. That describes how calls are routed throughout the voice infrastructure. And the dial plan in Asterisk is very rich. There are a lot of applications to do pretty much whatever you want, and if there isn't an application to do what you want, you can write your own. So that was very beneficial to us. So with that out of the way, take a moment to discuss the architecture rebuilt for the competition. So it was a pretty straightforward hub and spoke architecture. Last year I stated one of my friends did voice as a last minute add-on to the competition. So the night before, somebody was like, hey, we have all these phones, we should do something with them. And he had this awful full mesh SIP topology going that they were troubleshooting all day on game day. And I said, so this year we started real early, and I said, he said, Anthony, you're pretty good at Asterisk. And I was like, yeah, all right, sure. So I came up with the way we would do it. So basically every blue team had an Asterisk box. We installed the Asterisk service alongside of a regular scored box, so it wasn't a dedicated phone system. I think it was on the server that was being scored for SSH access. And so we just installed it right on there. Every blue team peered up with the white team server, and then the white team managed call routing throughout the architecture. So if team 1 called team 7, that call routing was handled by white team. But you had to keep your blue team box up, obviously, to receive and place calls. And then each team had a physical phone. So this is what that looks like. It's pretty much exactly what you'd expect a hub and spoke architecture to look like. Both white team and red team had their own phones, and those we hung them directly off of the white team call server. And then each blue team had their one phone, which they could certainly add more phones if they wanted to use a soft phone or something. And then their phone peered up with their server, and their server peered up with ours. So with that said, our approach toward vulnerabilities that we wanted to build in was to create these glaring, asinine vulnerabilities that would kind of give competitors an idea of where to look for vulnerabilities in a voice system. So typically the box that a blue team receives on game day is filled with ridiculous vulnerabilities. I know this year, notably on this particular box, every time you executed the service command, like service asterisk start or service asterisk stop, it would spawn a netcat listener. Last year they recompiled the SSH daemon to not use encryption at all. So any SSH going was totally unencrypted. And I remember they were talking about recompile. They had to recompile it and everything. This year on the web server, if you sent the web server an HTTP delete request, it would drop your firewall, it would reset your root password, and it would, I think it would also spawn a listener as well. So it's ridiculous. It's probably not things you're necessarily going to see in the enterprise, but the idea is we have students, we want to give them an idea of what kind of stuff they should be looking for, looking at netstat output, looking at, things like that to see what might be actually going on in their box. So I was thinking about this and I was setting up Asterisk. I realized that Asterisk will execute system level commands. You just change this live dangerously and set it to yes in your Asterisk configuration. And then if you set your Asterisk user to run as root, you can execute commands right from the dial plan as the root user. So that was the technical premise of how we approached doing VoIP security and doing VoIP vulnerabilities for the competition. And that allowed us to do some really fun things. So, once I realized that, I was originally just going to build a functional voice architecture, but once I realized we could do some more fun things, I said, okay, let's come up with an approach to make teams think a little harder about their voice architecture. So there were three ideas I had. I wanted to build in some kind of really obvious vulnerability that even somebody without any Asterisk experience at all could probably figure out and notice and say, hey, that shouldn't be there. I wanted to build in one thing that they just couldn't control, and then I really wanted to do something less obvious but way more fun. Things like, the voice equivalent of sending an HTTP delete request to reset the root password. So, excuse me, the first one I had, which was the one that should be obvious, is the white team extensions were used to provide technical support to blue teams. So if they had any sort of issue with their topology, or this was all virtual topology, so if they had a hypervisor issue, they needed a hypervisor password reset, something like that, they would call white team. So I built right into their dial plan just a very simple IP tables-f to flush their firewall every time they called us to help. In the words of one of the competition organizers, white team doesn't do work for free. So this is obvious. This is easy to fix. If you literally just look at the extensions.conf file, there's an IP tables-f, and you should probably wonder why any configuration file on your system is dropping the firewall. So I kind of wanted to build that in because people should probably notice it, one would hope. The next one that they didn't have any control over, I built with an asterisk queue on the white team server. Every time they called white team for assistance, we would randomly route calls over to the red team, the professional hackers. And that was funny because I was standing around on the day of the competition on the first day, and one of the red team members wandered over to me. He was like, "You're never going to believe this, but somebody just called and said, hey, can you reset one of our boxes?" I said, "Sure, what's your hypervisor password?" And they gave it to me. And I was like, yes. It made me so happy. And in the event that both white team and red team were busy, you got to listen to the serenading sounds of Where the Hood At by DMX as you're on hold music. So that was the Easter egg I worked in at 4 in the morning when we were putting together the competition. And at least 2 people got Where the Hood At, which made me unnaturally happy. But now the final extension, our equivalent of an HTTP delete request, was a system management hotline that each team had, which is basically a voice response system, like when you call to pay your credit card. And it had options to do things like drop your firewall, spawn a netcat listener, add an extra user. And to really make teams miserable, it would give you some long, obnoxious extension to punch in and then say, oh, you got to put it in binary. So they had to convert, like 935,000 to binary and then sit there and type in 1001. So we're testing this the night before with my friend. We're testing everything. We're sitting in the lab and he's listening to it and he's going, okay, 10, fuck. Hangs up, picks it up again. So I was, so my friend's doing that. I'm like, good. That's exactly what I was going for because I want them to hate their lives. So that made me really happy. And this is actually what that looks like specifically. This entire thing is scripted. I'll talk a little bit more about that. But you can see there are your the evil extension in this case would be for team 2. And if anybody in the architecture dialed 0283, it would sit there and read them this whole option set of menus to this whole menu of things you could do to the system. And then those are the decimal and binary equivalents of the numbers they had to enter in. And you got to pay to get a netcat listener. We really made that one miserable. So I had it in the billions at one point, but I was running into some problems. I was like, all right, let me scale back a little bit and not be that terrible to everybody. So So it was a lot of fun, and the way we implemented it was actually really straightforward. I mean, as I said, the dial plan is where you define your call routing and how extension passing is handled and how entries are handled. So we just made changes to the extensions.conf file. I kind of took a little bit of effort to hide things a bit. I threw some includes in there so people who were just glancing at the file wouldn't notice. And that was the case with that menu I just described. That was just a hidden include. I gave everything kind of inconspicuous file names, so hopefully people wouldn't notice them. And I scripted the whole thing. So every single blue team had a totally unique evil extension, and they had a whole unique set of binary extensions to enter in, which is pretty cool, I think, because with something like a lot of other vulnerabilities, it's vanilla. So once you discover it on your server or somebody else's, you can use the same thing against everybody. But this really kind of required teams to work for it if they wanted to discover it. Now the script is available on GitHub. I'm Critelli. If you decide to look at the code, should work on any Linux system running Asterisk. Please do not judge my scripting abilities by the quality of this code. I wrote it because I was trying to automate my testing process, and then it just kept growing and growing and growing. I said, well, this kind of sort of works. We might as well use it. And if you go back here, there's literally no error checking in the script anywhere, so it just assumes puppies and rainbows and everything works fine, which occasionally is not the case, and it'll throw disastrous errors. But it does work, and you can kind of get an idea of how we implemented things. So if you don't have any Asterisk experience, which I'm going to assume a lot of students may not, these aren't things you're going to necessarily pick up on right away. So they're going to kind of require you to dig in a little bit into the Asterisk platform to find them. So that was really what we were going for. So here's describe a little bit about the actual implementation. This is the extensions.conf file. And right on the second line here, is exactly what I was saying with dropping the firewall. So anybody who took a moment to look at one of the two config files that really matter on an Asterisk system should immediately pick up on the idea that we're dropping the firewall every time they call somebody, and should be able to remove that. And then right down at the bottom is that ISTS menu.conf include, and that's where we hid the main menu for that Trojan menu that I described. And if you look there right above, right here, this is the actual extension 0237 that would have been used to launch that menu. So to dig in a little bit to the actual code in the menu, we'll look at right here prompt 6. The sixth prompt was to spawn a netcat listener. So the Asterisk system would say the prompt, which I had a couple of friends of mine record, and then it would say a number, 953,757, and then it would tell you to enter it in binary, and then it would wait for you to do that. And then once you did enter it in binary, so once you entered this miserable string of ones and zeros, it would execute this script that we had written, which was basically just a shell script to spawn a netcat listener, and it would say goodbye to you because it's a polite voice system, and then you would be able to get you would be able to find a netcat listener. Next year's idea is to actually make it more interactive and say, okay, change the root password. What do you want to change it to? And let them enter it in and do things like that. But this worked for our purposes this year, and it was a lot of fun to do. So the question you might wonder is, why exactly did we do these kind of ridiculous things that you may not see every day in an enterprise? I kind of doubt you're going to see anything like this floating around your voice system, although, I don't know what you guys are doing for VoIP. So we focused less on the VoIP protocol vulnerabilities and more on configuration. And the main reason behind that is to kind of raise awareness that, and I'm going to talk about this more a little later, but to raise awareness that misconfiguration in the way you handle calling is a pretty serious vulnerability in a voice system. And so we kind of wanted to bring that into the minds of teams who may not have any voice experience at all. And this is especially true in voice over IP and SIP, because you're not just dealing with entering numbers into a phone anymore, you're dealing with packets. And if you're reading data from those packets, if you're reading headers in SIP, if you're reading the caller ID and things like that, and then you're using that within your voice-driven applications, that can present an attack surface. So that was kind of our goal. Another reason I didn't focus as heavily on VoIP protocol vulnerability this year is because, as I mentioned, implementation really is hard. And we were using these VIA phones, and there was basically nothing that we could do. I mean, we couldn't put certificates on them to do SIP TLS. We couldn't really get them to do SRTP, I don't think. So those were kind of some of the problems we ran into. So how did this all turn out? How did it work out for us in the competition? Well, from just an operational perspective, the script worked great, setup was smooth, everything worked. It was a beautiful thing. By 3 in the morning, we were done setting up the voice stuff, and I decided to lay down on the couch and take a nap. And I woke up at 4:30, and everybody was standing around the rack of equipment we had because the SAN had a problem. So they spent the next 4 hours trying to fix that. But the voice stuff worked, so go Team VoIP. And it was rock solid over the course of the weekend. We had 306 calls placed total. No architectural issues. Call routing worked exactly as we expected. It just worked well. And I had a couple people come up to me and say, man, last year, because we did voices, this last minute thing, they were like, man, it worked really well this year. And that made me happy. And by the end of by the final day, so it's a Saturday, Sunday competition, by the final day we only had 2 blue teams who were still paired up with us because everybody else's boxes were so hosed that they weren't even really considered with getting voice to work. They couldn't even log into them. So they had bigger fish to fry. From the perspective of vulnerabilities, by about 2 p.m. on Saturday, the first day of the competition, nobody except Red Team had really picked up on the fact that there was an entire system management console hanging off of the voice system. So we made it a bit more obvious, and that allowed teams to start using them against each other. And that was very telling to me because it was basically proving the theory I had before starting the competition, is that I'm willing to bet that if we put a voice system in front of everybody, they're going to have no idea what to really do with it except cross their fingers and hope their phone works. So the fact that nobody really picked up on this entire set of vulnerabilities we built right into the voice system was kind of telling to me in terms of where people's voice knowledge lies, which I thought was kind of good and kind of bad. So I'll talk a little bit more about that. But moving forward to next year, we would like to record and timestamp all calls. We certainly did not do that this year because we didn't tell competitors we were recording them, so that would be very illegal. So there certainly isn't a collection of phone calls on my laptop. I want to get call statistics. I would really like to get nice charts and graphs and pretty things like that. There are tools that will do this for Asterisk. And at 4 in the morning on Saturday, I was standing there setting up one such tool, and I was just hammering things into my computer, and I'm like, I'm not getting anything done. I'm too tired. So I took a break from that, and that's when I had mentioned we had an issue with the SAN, so I wasn't able to get back to that after I took a nap. But one of the unfortunate things that happened because of that is I turned off comma separated value CSV CDR collection, call detail record collection. So we ended up with that without any sort of parsable information on what calls were placed, and we certainly cannot use the file names from call recordings that did not happen because they didn't happen. So moving forward, I'd also really like to see some better voice injects and voice challenges. I would like to focus a little more on protocol security implementation. I would like to tell teams, hey, we want you to implement SIP TLS in your peering relationship between blue and white team. And that was actually something I labbed and tested before the competition and just didn't really have enough time to build a good operational way to do it. So that's on the agenda for next year. And I'd love to see a little more better voice challenges and voice bucket list items and chat and injects and things like that. And I would really, really like to make voice a scored service because it really should be. It's an integral part of any IT organization anybody will work for, and I would like some of the scoring to be based on that. And it presents a unique issue to score voice as a service in a security competition because most services like DNS, you can just query them and it'll return. If it returns what you expect, you say, okay, great. But voice, we have to query to see, okay, you're listening on your SIP port, great. Are you actually talking to the white team server, which would represent your service provider in the real world? Does your call routing actually work? So I have some ideas of how I want to do that. Probably do things like run checks on the white team server to see who's peered up, who's not, and if they're peered, try and run some test calls and things like that. So I do have an idea of how I want to do it. I just have to talk to the scoring engine guys who write that, and hopefully we'll be able to do that next year. Moving toward the future, as I mentioned, protocol vulnerability stuff, I really like to get better phones because these Avaya phones are a pain in the ass to deal with. And that's not because they're bad phones, it's because the idea right now in voice and unified communications is vendor lockdown on the system. So you buy an Avaya system and you put it in your rack and all your phones work. So you're not, they're not really designed to talk to Asterisk. They will do SIP and they will talk to it, but they're not really, there's a lot of caveats we run into. Ubiquiti Networks, if anybody's familiar with them, they make fairly cheap access points and stuff. They have these beautiful, beautiful Android-based phones that are basically this nice desk phone that runs a full Android runs full Android on it. And I'm like, these would be awesome because we could do Android exploitation on it and we could do voice over IP stuff on it. So I don't know if anybody wants to throw a lot of money at some really cool people, let me know. But that's on the agenda. And then I really would like, as I mentioned, do some instant messaging, do some unified communication stuff, kind of integrate it in more to what you might see in a medium to larger sized enterprise. So this is all fun, this is all cool, but where exactly do we build this into the real world? Well, this demonstrates a couple of things. As I mentioned, voice isn't always a well understood service. And your voice applications can be very vulnerable. They may not be as exciting as the vulnerabilities we built. They're probably not going to be because I doubt, as I said, I doubt anybody has a Trojan IVR menu hanging off their voice system. But the reality is that we're moving towards communication-driven applications. We're doing things like paying our bills via phone. We have been for a while. And we have to ask ourselves a question. Are those applications secure? Are the relationships that your voice system has with those applications secure, with those back-end systems secure? A good example, there's a file in the Asterisk source code called readmeseriously.bestpractices.txt. And it takes this example right here that I have, this 500 and SIP / and all that crap. And it's basically going to the idea that signaling packets are packets, that you're ingesting text data. If you're ingesting that into your applications, you have to make sure you're doing proper input and output sanitization, because in this case, this would not only dial extension 500, but it would also tell the SIP channel driver to dial an external call. So, like I said, we're not just dealing with numbers anymore, and that's very important. So this poses some serious challenges for administrators and implementers of voice systems. We have a publicly facing voice system that's interfacing with internal systems. We have to make sure we're auditing that correctly. We have to make sure that we're not just, scanning the Linux box and saying, yep, looks good, but are we actually auditing the voice applications like we may audit any other externally facing application, like a web application, for example. So those are important considerations for as we move toward communication-driven architectures. So, and then in the case of protocol security, we have to ask, how are we implementing that? How are we implementing it in a mixed vendor environment? Is our current implementation, if it's one vendor, scalable to the idea that in 5 years we may say, hey, I'd really like to get this soft phone by another vendor? Will that work with our system? If you're using security as a checkbox, what is it actually doing? What does that mean? Sniff packets is, if you're checking security, is it just doing SIP encryption, signaling encryption, or is it encrypting your media as well, and how? And does that work for you? So that's important. And then as you peer up with the outside world to make external calls, as people typically move toward buying SIP trunks now instead of standard telephony trunks, how is your provider implementing security? Are they doing SIP TLS? Are they doing, are they taking the proper measures to ensure that your voice traffic is secure? And this is very important because people have a certain expectation of privacy with voice that they may not with other systems, because they've been using voice forever and they just assume that their voice system is going to be secure. So these are important. So some takeaways I'd like to bring to anybody here who's either a competition organizer or a competitor of a security competition. If you're an organizer, build voice into your competition. Do cool stuff with it. It's a lot of fun, and it could really present a learning opportunity for your competitors for a service they might not be that familiar with. Build good injects and challenges that push teams to do things like secure their voice system, to integrate their voice system with other systems that they're responsible for. And then make your vulnerabilities cool, because that's obviously the most fun part. Let's be real. And also integrate voice in the spirit of the competition. So we would, since each team, blue team, does represent an IT department, we called them and we pretend to be users, and then we'd be confused and ask them for tech support help, and then get really belligerent with them. There's a great video of me on Facebook from a couple years ago just screaming and insulting some team and trying to get them to calm me down. And they did a good job, and they scored well for it. So, use the actual voice stuff too. Don't just use it as a vulnerability platform for your competition. And then take advantage of things like Asterisk or Free PBX or any of the number of hundreds of smart soft phone clients that exist out there if you're organizing a competition. And if you have any questions, my contact info is in the slide. I'd be happy to help you build a really cool voice architecture for your competition. Now, if you're a competitor, know your voice system, because everyone is different. Asterisk is different from Free PBX, which is different from, God forbid, Cisco Call Manager Express, which is different from every God in the world forbid any sort of Avaya platform. It'd be insane if they gave you that in a competition environment, just because it'd be so expensive to do. So know your system and know the clients you're going to be using. Soft phones will use predefined ports for RTP in some cases. Soft phones and voice software have specific vulnerabilities. So There was an email last night on one of the SEC mailing lists about, it was a couple days ago, about how Asterisk is open to accepting arbitrary certificates for SIP TLS if you put a null byte. It's vulnerable to a null byte vulnerability in SSL. So, know the system, know the platforms you're going to be using, because they are just software platforms and may have their own vulnerabilities. And get offensive. Do things like war dialing, scan the SIP network, play with some of the tools. Kali's got a lot of built-in tools. Scapy has built-in SIP signaling abilities, so do stuff like that. And then, of course, learn. I really enjoyed this. I got into doing voice stuff about a year ago on my own, just because I took a VoIP class at school and really kind of went above the coursework because I thought it was really interesting stuff. So that's what I encourage you to do. And as I mentioned, tools and tactics, there's a fantastic article on the Backtrack Linux site about assorted vulnerabilities, their implementations, and then assorted tools that you can use to execute attacks against those specific voice vulnerabilities. This is a great article, describes tools for extension enumeration, for call capture and playback, which you can actually do right in Wireshark. And then Metasploit has some SIP functionality, some SIP modules built in, as well as some platform-specific exploits for, like Asterisk or FreePBX or something. So to kind of wrap up, I would really like to thank and provide links more specifically, because these slides will be online. RIT SPARSA, the Security Practice and Research Student Association, blue, white, and red teams of Information Security Talent Search 12, and then the Department of Computing Security for piquing my interest in this topic. And with that, thank you for listening, and I'd love to open up to some questions and comments. I think I was told I have 10 minutes left, so yeah.
What's your opinion of more commercial systems like you can buy at Best Buy, like UMA?
So I've never used UMA. I think typically if I'm doing something in an enterprise, I would always be skeptical of something I pick up at Best Buy. A lot of the common way to do voice in an enterprise right now is to buy like a Cisco system or an Avaya system and then pay atrocious amounts in licensing. But I think if you have somebody who's willing to be a subject matter expert in a system like Asterisk or a platform like FreePBX, and is kind of willing to go the extra mile, you can get it running a good enterprise voice architecture running on something like that. And those kinds of systems, the free software is particularly conducive to, like I said, building voice-driven applications in your enterprise. And that's not really the answer you're looking for. I'm just not too familiar. I've just never used it. But anybody else? Cool. Well, thank you for your time. Appreciate it. Hope maybe you learned a little something today. My contact info is on here. These slides will be on my site, and let me know if you have any questions. And enjoy the rest of your B-sides, and go eat lunch.